For a few minutes, the sun can disappear in the middle of the day. The sky darkens, temperatures can drop, animals can become confused, and millions of people may suddenly find themselves standing beneath a shadow moving across Earth at thousands of kilometers per hour. But an eclipse isn't the sun disappearing. It is something far more precise. A cosmic alignment involving the sun, moon, and Earth. And when the geometry is just right, the moon can briefly hide one of the most powerful objects in our solar system. So what actually happens during an eclipse? And why doesn't this happen every month? The answer begins with something surprisingly simple: shadows. A solar eclipse happens when the moon moves directly between the sun and Earth. Normally, sunlight travels through space and illuminates Earth. But during an eclipse, the moon blocks part of that light and casts a moving shadow onto Earth's surface. From inside the darkest part of that shadow, called the umbra, the sun can appear completely covered. This is a total solar eclipse. For a brief moment, the bright surface of the sun disappears, leaving only its faint outer atmosphere, the corona, visible around the black disk of the moon. But here's the strange part. The moon is about 400 times smaller than the sun. So why can it cover the sun? Because the sun is also roughly 400 times farther away. That extraordinary coincidence makes the two objects appear almost the same size in our sky. And that's what makes a total solar eclipse possible. But if the moon, Earth, and sun are constantly moving, why don't we get an eclipse every month? Because the moon's orbit is tilted. Most months, the moon passes slightly above or below the sun from our perspective. Only when the three objects line up closely enough does the moon's shadow reach Earth. And when it does, something remarkable happens. Daylight can fade within minutes. The horizon may glow with strange colors. Temperatures can fall. Some animals behave as though night has arrived. And the moon's shadow races across the planet. But a solar eclipse isn't the only kind. During a lunar eclipse, Earth moves between the sun and moon. Instead of the moon's shadow falling on Earth, Earth's shadow falls across the moon. And the moon can turn deep orange or red. Why? Because some sunlight passes through Earth's atmosphere first. The atmosphere scatters much of the blue light, while red and orange light can continue toward the moon. So the moon is essentially being illuminated by the light of every sunset and sunrise happening around Earth. But perhaps the most incredible part is this: an eclipse is not just something happening in the sky. It is a demonstration of how precisely our solar system moves. The Earth rotates, the moon orbits Earth, Earth orbits the sun, and every once in a while, their paths align so perfectly that a shadow from one world sweeps across another. Big picture. For thousands of years, eclipses terrified people because they didn't understand what they were seeing. Today, we can predict them years in advance. We know where the shadow will travel, when it will arrive, and how long it will last. Something that once looked supernatural has become one of nature's most predictable and spectacular events. An eclipse is simply a shadow, but it is a shadow created by three worlds moving through space with extraordinary precision. And for a few unforgettable minutes, that shadow reminds us just how enormous and how perfectly ordered the universe can be.